Well, I need to TIG these spacers to these brackets. These are for the 710. I've been putting it off for a couple of weeks now, working on the lathe. One needs to go out the door. Should have gone out the door weeks ago, but he's been pretty patient. Anyway, so what I did was, I was thinking, I could set up a jig and blah, blah, blah. And I finally decided, you know, these are the bolts that were too short that I ordered. So I basically put them in there, got them clamped in and that stuff. And now I can drop a bracket on, drop those two on, tack them, yank it off, and put another one on. And for the other side, I just do the other brackets like that. Oh, and I didn't, I wire wheeled oh yeah, this one goes. I wire wheeled the sides that need to be done, so hopefully that'll help catch me. I've got two different piles, lefts, rights, so I want to make sure I get them correct. So let's see how it goes. Now those are nice and clean and pretty and certainly strong enough to hold it for mounting. The thing is I may add a little rod to each one. Reason being is I have to put them in the mill and shave them down to the correct height when I'm done. So too much heat, it lifted up. but you can see it's lifted up a little bit on the end there. So my challenge is that there's a left and a right. I had all of these cut the same way because this plate is a mirror image left to right. The problem is that means that this plate bows this way up toward here when I start shaving these off. When I do the other one, they're going to bow the other way. Now the reality is that I need them to be 1.25 inches from this surface, okay, from the mounting. I could put these in the mill and shave both sides. If I shave this side, you know, it'll shave all of this until it gets down even with that. When I flip it over, it'll shave this, you know, because it'll be bent the other way. It'll shave this end until it gets down even with this. Now that's a lot of friggin' work, shaving both of them down and everything, and it kind of kills the whole reason for having them laser cut. Now next time I may consider having left and rights cut, and then that way they all bend in the same direction and I won't have to fight with it so bad. Alright, so what I've come up with here, my main concern is the height of this surface from the backside of these two mounting holes, okay, because that's where it pushes up against the strut, okay. So I don't care really that it's bent. It can't be bent so much that the bolt can't go through, but these holes are a little on the bigger side because it's DOM tubing and it's not precision drilled. So if I can clamp it down and get that surface area flat and accurate, that's basically right at these mounting holes, then I can machine this and know that it is the right height from the backside to here and that it's parallel with it. Okay, so that will correct any of this bow on the end here, whether it's up or down. Okay, if it fades away, that means this end's going to be a little longer. If it fades up, bends up, then this piece is going to be a little shorter. So if I measure each end individually with the calipers, I will see a difference. You know, this will be 1.25, this will be 1.21, you know, something along those lines, depending on exactly how much that bent up this direction. Okay, and then that gives me 2.259. Subtract the 1 inch, and I'm 9 thousandths too tall now. And that says 59.5. So I'm happy with that as far as how the cut is. That I'm within, you know, 0.5 thousandths there roughly. From side to side. So I'm tickled pink with that. I still got to drop it down, you know, 9 thousandths. But so this is saying 55. And I'm not exactly, I haven't cleaned up all the burrs and stuff like that yet, so oh, just trying to, couldn't get past the block there. Okay, and then this one says 49. It moved slightly, but it was saying 49. So, you know, that shows me that there's about a 6 thousandths of bend in here. But with the way I've done it, I've compensated for it so that you can see that when it bolts to these two, the bend that's out here on the end, because of the heat from these two holes in the plate being so close together, that has caused it to bend up a little bit. I'm getting it nice and perfectly flat. So, you know, if you measure one end to the other, they look a little off, but when it's mounted, they should be right on the money. And that'll be the opposite when I flip the other ones over and they curve down. And I'll make sure that the block doesn't extend any further than it does here, because I want to simulate that it's on the mounting pad of the strut tube, okay, the spindle. All right, there's that. Nice, right on the money. God, right on the money. They're both within a half a thou there. You know, I mean, as accurate as I could hope to get with this pair of calipers. Yeah, wow, nice. Easily within a thou. I'm happy with that. It's kind of a pain in the butt. These are about 70 thou too long when I tack them on. So I'm glad I did this testing before tacking all of them on. So what I'll do is I'll go throw each piece back in the lathe and I'll chop, you know, another good 50, 60 thousandths off there so I can trim these down with one pass instead of two. Yeah. Now I have to watch it though. I can't cut it right down to, and I'm glad I cut them long, because when this fades away, doing the other side bracket, I'll need them a hair longer. So instead of having to make them, you know, if I cut them right to length, and there was a 6,000 drop, I'd be 6 thousandths too short here. So it's a good thing I did it, because if I have to machine both faces, then it's going to be too short too. So yeah, so this is part of the figuring out process. It's one thing to design the bracket, but then, you know, you got to figure out how to, you know, actually make it, how to do the manufacturing, because the CAD world and the real world aren't exactly the same. I can design this in CAD and, you know that this is supposed to be exactly 0.875 for both of these. But in the real world, with that laser cutting and the bend, I either have to figure out how to compensate for the bend like I'm doing, or I have to figure out how to get rid of the bend. If these were water jet cut, I wouldn't have a problem with the bend. If they were machined or milled, I wouldn't have a problem with the bend. But in order to keep the cost down, laser cutting is by far the best way to do it. So the other option too is next time not having the holes cut, okay? Or I could possibly have, you know, one hole cut, two holes cut maybe, so I could register it and drop it onto a jig on the mill and then just drill the other two holes. Or I could make a jig that anchors to the outside dimensions, and then I could just drill all 4 holes. Now with a CNC mill, that would be really nice, because I could just put a bunch of these down on a pallet and just punch all the holes. Piece of cake. But, you know, that's not, I don't have one yet, so gotta do it in a way that I can do it.